Okay, this is TempleOS 5-minute random code walkthrough, episode 35, and I'm your host, Terry Davis. So I started this session, and my recording session got interrupted, so I have to start over. The random pick was in XOR. This is the optimizing portion of the compiler pass. The optimizer has roughly 10 passes, and this is on 0, 1, and 2. And the XOR operator. So to understand what I'm talking about, let's say you have I64I, if I XOR, let's do it J, IJ, true, else. Actually, I can do it. I'll show off. These are okay. Let's make this I bool A, comma, bool B is XOR. Let's just call it that. Is XOR. True, comma, true. Okay, well, we don't need to show off our mastery of logic. Oops. Okay, so we have false, true. So XOR, okay. So what's happening? So on pass 0, this is what the parser makes. It takes RBP, 10 off of RBP is argument 1, and it adds 10 to RBP, then it dereferences. So that's the first one. The second one is RBP, and 18 is B, adds RBP and 18, dereferences. That's the next one. Then it does XOR and branch if 0. So going into pass 0, we have this situation, and by the time we do pass 0, 1, and 2. By the time we do 0, 1, and 2, we convert to okay. Nothing happens. Okay, well, let's go ahead and take a look what's going on. I think this is for constants. So if we say, now, okay, so we did that. That's not very exciting. The code did not do anything. But if we say true or true, and now we have immediate XOR branch, then we have immediate branch. So what it did is it simplified the constant. Now this is the optimizer. It's simplifying constants. This is not the final. Some people think this is a bytecode interpreter. No, it's not that. It's simplifying constants in a compiler. At the very end, we do. This is compiled code. Anyway, so let's look at now that we know what we're doing. So when it goes through the byte code, the intermediate code, and it starts. These TempleOS are the intermediate code nodes, structures, and when it gets to 0, it's the end of the list. Here's what it does. It has the intermediate code is for a stack machine, and when we're simplifying, it's as though we're doing a byte code execution, but and we're if it has one argument, two arguments, or variable arguments, we're popping the virtual machine. This is the byte code stack. It's like we're executing. It's like we're executing a stack machine, and then so in the main loop, this loop is huge. This loop is okay. So that's the loop. Anyway, so it's a big switch statement. If you know, a switch statement is really, really efficient. It's just a single jump. Some people think it's if else. I can't believe that. Anyway, so based on the code, this is the XOR XOR. We jump into a switch statement with all these cases, and so when we hit the XOR XOR, this is I have groupings of switch statement operations. All these operators are grouped together in a what I call a sub-switch start. So there's, I don't know, roughly, what is there, 200 different intermediate codes, and all the operators, there's things besides operators, but all the operators are grouped together, and when they finish when they hit a break, then they drop down and do this common code. So this happens to be the very last operator, fix up binary operator number 1. Now this is a common, all these operators call that routine, and all it does is it converts, it deals with float to int conversions and figuring out the type. So int is int float is float. Anyway, so these figure out if it's constant, it returns a code. So this is fixed binary operator 1 not constant is what that says. Fixed binary 1 float, fixed binary 1 not constant. So if we have an immediate and an immediate, then it's going to return a constant. Oh. I have to get my bird. So I do believe it's going to say it's an int. So if it's an immediate and it's not a 3-part or something like that, then it's a it sets them both to no op and says and it returns an int. So the no op does not affect the data in those two immediates. Wow, that's kind of dangerous, isn't it? Anyway, so we take the data from the two arguments to. There's a pointer to the intermediate codes for each argument, And here we XOR them and replace it with an immediate. And then we set the type to an integer. XOR is always, this is a logical, this is not just XOR. This is a Boolean XOR, so it's always integer. And here we can never have float, but this is checking if it's float. Anyway, so that's the story.